Welcome to the deep dive.
It's good to be back.
So today we're zeroing in on a single really strategic moment. We're looking at the opening remarks from CEO Jensen Huang during Nvidia's Q3 2026 earnings call.
Yeah, and this was much more than just a financial update. He laid out a whole thesis for why this massive infrastructure boom is, well, not just hype.
Exactly.
So our mission today is to really dig into that. We're going to analyze his rebuttal of the whole AI bubble story and, more importantly, break down what he calls the three massive platform shifts that are all happening at once.
And this should give you a really clear, structured way to understand the logic behind, all the tech investment we're seeing right now.
It's a roadmap directly from the architect.
Okay, so let's start where he did. He went right at the elephant in the room, or I guess the elephant in the data center.
He did. He immediately confronted that whole AI bubble narrative.
He said he sees something very different. So before we dive into the three big shifts, what's his foundational counter-argument? Why is this demand structural and not just, a temporary boom?
Well, his initial point, it really comes down to versatility in history. You could call it their software mode.
Okay.
He argues their technology isn't just for one piece of the AI puzzle. It excels at all of it. So you have the pre-training of the models, the post-training and refinement, and then the big one, inference.
That's actually running the models for users.
Exactly. And that whole spectrum is something most competitors really struggle to handle seamlessly.
But you said versatility in history. And the versatility part goes beyond just AI, right? That's what I think gets missed in a lot of these discussions.
Absolutely. This is where the structural argument really gets its legs.
Yeah.
He points to 2 decades of investment in the CUAX acceleration libraries.
And we should be clear, CUDA isn't just a piece of software.
Not at all. It's the entire programming model. It's this critical layer that lets their hardware speed up so much more than just generative AI.
So what are some of those other workloads, the non-AI stuff that still costs a fortune to run?
Oh, we're talking about huge established industries. Things like large-scale science and engineering simulations, advanced computer graphics, structured data processing, which is basically the engine room of modern business, and even classical machine learning.
Which still does most of the heavy lifting.
Right. So his point is, if the generative AI hype cooled off tomorrow, the underlying demand from science, from engineering, from data analytics, it's all still there.
Yeah.
And it's all built on that 2-decade software investment.
That makes the whole foundation much, much less wobbly, less susceptible to, the latest trend.
Precisely.
Okay, let's get into the core of his thesis then. These 3 platform shifts that he says are compounding right now. The first one he calls the foundational shift.
Right. The move from CPU, general purpose computing, to GPU accelerated computing.
And why is that foundational? I mean, why isn't it just another upgrade cycle?
Because it's being forced by physics. And that translates directly into economics. He called it foundational and necessary in a post-Moore's Law era.
Moore's Law being the idea that chips get twice as powerful every couple years for the same cost.
The predictable doubling, yeah. And that has slowed way, way down. So we can't just rely on general-purpose CPUs to get faster and cheaper on their own anymore.
So if you're, say, a CFO at a big cloud provider, what does that mean for your budget? That's where the total cost of ownership, the TCO argument, comes in, right?
Exactly. The TCO for just sticking with CPUs is getting out of control. Energy costs are soaring. You need more physical space. He points out that the hundreds of billions spent every year on CPU cloud computing for all these existing workloads, it's just becoming unsustainable.
And accelerated computing is the way out.
It's the escape hatch. GPUs give you so much more performance per watt for these kinds of parallel tasks. So switching isn't just about going faster, it's about survival. It's about lowering your long-term costs, your energy bill, and actually protecting your profit margins.
And he said this shift has reached a tipping point.
Because the economic pain is now unavoidable. It's a necessity.
That makes sense. But okay, if this is so foundational for the whole industry, why aren't competitors like Intel or AMD capturing more of that spend?
And that comes right back to the software mode, to CUDA.
That 2-decade head start.
It's a huge head start. I mean, other companies can make good hardware, great hardware even, but they don't have that seamless software ecosystem. Yeah. Think about the cost, the time, the risk of trying to move these massive, critical, non-AI code bases from a CPU architecture to some new non-CDA environment.
It's a massive undertaking.
It's prohibitive for most companies.
Yeah.
So you're not just buying a chip, you're buying into a stable, integrated development platform that massively de-risks the whole transition for you as a customer.
So the competition is fragmented and their platform is unified. It's the safer bet.
It's the lowest risk CapEx choice for your foundational needs. Yes.
That's a powerful argument. Okay, let's move to the second shift he outlines. He calls this one the transformational shift.
This is all about generative AI. Specifically, how it's transforming existing applications and replacing classical machine learning.
And what's so fascinating here is that the focus isn't just on new chatbots. It's on optimizing the biggest, most profitable online businesses in the world.
Exactly. The hyperscalers. Generative AI is being plugged into the systems that already make them billions. We're talking search ranking, recommender systems, ad targeting.
All the core money-making engines.
He says it's transforming the very foundations of hyperscale infrastructure.
And he gave a really powerful, concrete example of the ROI here, the return on investment, the one from Meta.
A stunning example. Their GEM foundation model, which they're using for ad recommendations.
Remind us of the numbers he quoted. They were incredibly specific.
Yeah, he said that one single change to a generative AI model led to a reported 5% increase in ad conversions on Instagram.
5%. And on Facebook.
A 3% gain on the Facebook feed.
For a company at Meta's scale, a 5% lift isn't an optimization. That's billions in new revenue.
Potentially, yes.
But let me push back on that a little. Is this really a sustainable transformation? Is it creating new value, or is it just a zero-sum game where companies use AI to steal a little bit of market share from each other?
That is a critical question. And I think his thesis would be that it's structural because the gains are realized by the platform itself. It makes their service fundamentally more valuable to advertisers. And when you see what he calls substantial revenue gains for hyperscalers,
the spending on the GPUs just becomes a no-brainer.
It's immediately justified. It stops being the speculative bet and becomes a capital expenditure that delivers a measurable, profitable return, like right away.
And that creates a feedback loop.
A self-reinforcing cycle. The better the AI gets, the more revenue you make, which funds more investment in the AI infrastructure.
That clarity on ROI is key. It really separates it from just, tech hype. Okay, that brings us to the third and final shift. He calls this one revolutionary.
The rise of agentic AI systems.
We hear that term agentic thrown around a lot. What does it actually mean in his framework?
He sees this as the next frontier of computing. So an agentic AI is a system that can do more than just answer a question. It can reason, it can plan, and it can use tools on its own to complete complex multi-step tasks.
So it's the leap from a chatbot to an assistant, or even a surrogate worker.
Exactly. And he calls this revolutionary because it's not just optimizing old businesses. It's creating entirely new applications, new companies, new services. It's pure net new economic activity.
And the examples he gave really show the breadth of this. It's not just one thing.
It's incredibly varied. You've got coding assistants like Cursor and Claude Code that are changing how software is written.
Developer productivity goes through the roof.
Right. Then in really high-stakes fields, you have things like ADOC in radiology or Harvey for legal work. And then maybe the most visible example is physical AI.
The AI chauffeurs?
Tesla, FSD, Waymo. These are actual robots carrying out complex plans in the messy, unpredictable physical world.
It's interesting, though, that he separates this out as a third revolutionary shift. Couldn't you argue that a coding assistant is just a very sophisticated form of generative AI doing an optimization task?
That's a great point, and the distinction is strategic. The transformational shift, that's about making an existing system better, making ad recommendations 5% better. The revolutionary shift is about creating entirely new capabilities. A self-driving car doesn't just optimize traffic, it changes the entire concept of transportation and labor.
And an AI that writes half an engineer's code isn't an optimization, it's a revolution in productivity.
That's his argument. By separating them, he's highlighting that the demand for infrastructure is coming from three very different sources of future value, not just two sides of the same coin.
And he names the pioneers here: OpenAI, Anthropic, xAI, Google.
All the companies pouring billions into this new waves of autonomous systems. And they all need an architecture that can handle anything, from training a massive language model to simulating the physics for a robot.
Okay, so let's tie this all together. We have three huge, distinct drivers of demand all hitting at once: foundational, transformational, and revolutionary. The big question is, Why is one single architecture the platform for all three?
And that is the absolute core of his entire argument. His claim is that their singular architecture enables all three transitions.
It's the unification.
It's the unification. The strategic value isn't just that it's good at one thing, it's that the customer doesn't have to bet on three different fragmented, possibly incompatible systems to ride these three different waves.
So if you're a big cloud provider, you're facing this foundational economic pressure.
Right.
You're trying to get those transformational revenue gains, and you're also trying to innovate in this new revolutionary agentic space.
All at the same time.
Yeah.
And without a unified platform, you'd need, what, separate hardware for your scientific computing, different clusters for your LLM inference, and maybe some other specialized processor for your robotic simulations. The complexity and the cost would be insane.
And the risk.
The financial risk of that kind of capital spend would be enormous. The unification just dramatically lowers the complexity and the risk.
So in his view, the investment is structural because the platform is this triple threat engine. It handles any kind of AI, any modality text, images, biology, physics, and it works everywhere from the cloud down to a robot. It's the safest bet for riding three massive economic waves at the same time.
That's a perfect way to put it.
Yeah.
The market valuation isn't based on the size of just one of those waves. It's based on the compounding effect of all three hitting a single unified bottleneck at the exact same time.
So to wrap this up for you, the CEO's core message is that this incredible sustained investment we're seeing isn't about hype. It's driven by the convergence of three massive independent platform shifts all happening at once. A foundational shift in how we have to compute, a transformational shift that guarantees immediate returns, and a revolutionary shift creating entirely new industries.
And that leads us to the final thought for you to take away from this. He very carefully classified these shifts: foundational, transformational, and revolutionary. So the question is, what happens to the rate of technological change and to the market's conviction in a single platform when you have three distinct economic drivers, each one big enough to create trillions in value on its own, all being accelerated and unified by a single architecture at the same time? That is the unprecedented scale of change he's betting on.